Is there a business case for in-storage data processing? There is, and I'm going to explain why. Hi, I'm Peter Nichol, Data Science CIO. Computational storage is one of those terms that's taken off in recent years that few truly understand. Computational storage is all about accelerated processing and programmable computational storage. The idea is that when we have our data far away from our compute, it not only takes longer to process, but is actually more expensive. This is common when we have multi-cloud environments where we have to move and egress data out of our environment at very high costs. The closer we can move that data to our compute power, the cheaper it's going to be, and ultimately the faster we're going to be able to do those calculations. So here's some examples. First off is hyperscalers. These are being used to do things like AI compute, high throughput video processing, and even composable networking. When we look at organizations like Microsoft, their Bing product and their search engine is using field programmable gate arrays, which is essentially accelerated hardware, to do things like search engines and be able to provide those search and analytical results in almost less than microseconds. As we transition to other capabilities like map reduces, when we see architectures that are highly distributed like this, that are very effective, it's a great foundation to be able to scale the computational compute capabilities. Even when we look at AWS Lambda, that's typically a data streaming capability, we can start to program those and cut away those data streams so they're individual fed and funnel one of those data streams from AWS Lambda into computational storage. And now what we've done is we've not only made that stream more efficient, but able to process that compute even faster. So why do we even care about computational compute anyways? What we realize is when we look over the last year or even the last decade, the way that we store data is all designed and architected based on how CPUs are designed to process that data. And when we look at how CPUs are designed and architected, that architecture from the last year to, say, 10 years has dramatically changed. And as a result, we need to change how we store data to process it more effectively, faster, and at cheaper costs. Snowflake is a good example of a product that separates the compute from the storage processing. And as a result, it's a great opportunity for business leaders to realize the benefits of separating the compute from the storage, and provides different types of capabilities and benefits for us as technologists when we're trying to design these architectures. So as you think about your environment and how you're leveraging and processing data, start to keep in mind how far away your data is from your ability to compute that data and process that data analytically. I'm Peter Nichol, Data Science CIO. Have a great week.